Welcome students to Future Kind Academy. With me, Mr. Perike, as your tutor. In physics today, for those that are in senior classes, that is grade 10 to 12, continuing with motion. Now today we are looking at equations that are used in motion. We want to see how can we use these equations as well as how best can we come up with these equations. Remember, we have defined all the terms already. Now, under the first equation, we are deriving it from this, which is A, acceleration is equal to V minus U over time. Now, this equation, under this equation, we can use it to solve acceleration if we've been given velocity as well as initial velocity as well as what? Time. So A is equal for acceleration, where V is equal for final velocity and U is equal for initial velocity and T is equal to time. So we can make V the subject of the formula by saying A is equal to V minus U over T. Over 1, we cross multiply. We've got V minus U is equal to 80. So V is equal to this one we cross. We are going to have 80 plus U. Others write V is equal to U plus 80 as our first equation. V is equal to U plus 80. V is equal to U plus 80. That is the first equation. How can we solve? When we are looking at velocity, meaning, example, they have given us equation, a car started from rest, and accelerated to a certain point in 5 seconds. Calculate the final velocity if its acceleration was 2 meters per second squared. That is the question. When can we apply that formula? When can we apply that formula? Now look at the question again. Systematically, we are saying a car started from rest. Now that word rest is telling us to say the initial velocity, where this car started from, it's 0 because it was at rest. So now we are going to say V is equal to U plus 80. That is our formula. In our question, we are finding the final velocity. V is equal to U, which is the starting point. We said it's at rest. Therefore, our initial velocity is 0. Plus, what is our A? We've been told to say acceleration was what? Was 2 multiplied by. What is our time? We've been told to say it's 5 seconds. So we have 5 there. So our V is equal to 0 plus 2 times 5, we are going to have 10. So our V, 0 plus 10, it will give us 10 meters per second. And that is how we apply the first formula when we are talking about velocity. Now, this is a key point. When they did not mention the initial velocity will always be 0. Or when they say this object started from rest, then your initial velocity is what? 0. Pick that point. Even on a graph, you are supposed to know that. Let's go to the second formula now. In the first one, we are looking at finding velocity, but under the second one now, we are looking at distance, which is s or x. This symbol represents distance. Distance is equal to ut plus half at squared. Now, here s or x is equal to distance, u is equal to initial velocity, as well as half, we have it already, it's in digits, and then a is equal to acceleration, t is equal to what? Time. So these, they help us to find what? Distance. A very good example, let's have a question which will use that formula. We are saying a body which was at 10 meters per second accelerated for 5 seconds to reach a certain speed. Calculate the distance covered by the body if its acceleration was 3 meters per second. Now, a body which was at 10 meters per second accelerated for 5 seconds to reach a certain speed, calculate the distance covered by the body if its acceleration was 3 meters per second squared. Remember, acceleration is supposed to have square. And now we are solving distance. Our formula for distance, s is equal to ut plus half at squared. We replace our s, the one we are solving, u, initial. In this question, our initial said is started from 10 meters per second. So we have got 10 multiplied by, what is our time? Our time, we've been told to say it's 5 seconds. So 5, we are multiplying, plus half. What is our a? Our acceleration is 3 multiplied by, what is our time? Our time is 5 squared. We are there. We'll go. Now, this is what we have. This is what we have. We have s is equal to, what is 10 times 5? You are going to have 50 plus half times 3, and then 5 squared. If you've got 5 squared, you're going to have 25. 5 squared, you're going to have 25. Now, here again, we have what we call s is equal to 50 plus 3 times 25. You are going to have half times 75. And then our S is equal to 50 plus half of 75. Meaning this 75, we are dividing it into 2. So over 2, 2 into 7, it's 3, remainder 1. We know that. 3, remainder 1. 2 into 15, we are going to have 7, remainder 1. We put a point, add a 0, 2 into 10, it's 37.5. So now, we are going to say our S is equal to 50 plus 37.5. You add the 2, which is 50 plus 37.5. This is 5 points. You've got 7 and then 87 meters. That is our distance. So that is how you calculate distance when it comes to the second formula, where we have S is equal to UT plus half 80 squared. Just replace, follow the question, replace where and then find what is missing. A very good formula. When do we use it? When we have not been given the final velocity, you can apply this formula. We move on to the third and last for today, the last formula for today. Formulas that are used in motion. The second one, we've got V squared is equal to U squared plus 2AS. V is equal to final velocity where U is equal to initial velocity as well as A is equal to acceleration and S is equal to distance. So if you have been given distance but you do not have time, you can use this formula to find velocity. Last example, e.g. an object covered a distance of 20 meters when it was accelerating at 5 meters per second squared. Calculate its velocity. Calculate its velocity. Now, here we've been told to say this object or this body covered a distance of 20 meters. Covered a distance of 20 meters. Now we're looking at this one now. This 20 now. This 20, it was accelerating at 5. Now, again, it reached at that one. So now, what we are going to do, we'll say V is equal, V squared rather, is equal to U squared plus 2AS. Our V squared is equal to, our initial is not stated, so it's 0 squared plus, what is our 2? Our acceleration is 5, comma, multiplied by what? 20. Multiplied by what? 20. And then our V squared is equal to, this one is 0. 2 times 5 is 10. 10 times 20 will give us V squared is equal to 200. It's equal to 200. And then our v squared is equal to 200 square root. So we are going to have v is equal to the square root of 200. You use a calculator, you can find it there, the square root of 200. It's just a direct. But if we had a 10, we would have just said v is equal to square root of 100, which v will give us 10 meters per second. And that is our velocity. So for now, we end there, students. And remember to use these formulas when we are solving questions to do with motion and we do not have graphs. So in our next lesson, we are going to look at representation of data on a graph. Follow along and try as many questions as possible. For now, bye-bye.